Hello everyone, I hope you are well. I hope the exams are going very well for you. Do say hello in the comments, it'd be great to introduce you and to welcome you along. Right, today we're on the last part of our travel through networks and topologies. So while I sort of talk through what we're going to go through today, I thought maybe you might want to start by answering one of these very simple questions. And this takes us back to last week. So do get your answers in. Hi Swiftblade, how are you? Nice to see you. Let's get you up there. Hi Swiftblade. 6 likes already. I'm winning the game. Not quite sure what the game is, but I guess I'm winning it. So that's good. Last week was the loneliest experience on Earth, but if I don't send out the link to let you know what I'm doing, then that's probably my fault, isn't it? But great to see you today. So what do we think? Which of these is, which of the following are not usually in a compressed format? This is unhelpfully the one that I didn't do because I was ill, but I'll do it at the end. Anyone picture which one of these was actually in a not usually compressed? JPEG, bitmap, MP4, or MPEG? Any ideas, anyone? Is that what you did? You're a good man. I will pay you for this Swiftblade tomorrow. So that's outstanding. I had a look to see how many viewers, how many subscribers I have to start making money, and I think I'm going to be a teacher for a long while yet, is all I can say. So, oh, hello. So we've got Hash Brown Gaming. How are you? And yes, you're absolutely right. That is completely the right answer. Let's just push on to there then. It is bitmap. That one's not compressed. All the rest are compressed. It's sort of lossy compression. Swiftblade said B as well. Outstanding. Emad. Hi, Emad. Said B. Hash Brown Gaming. Hello. Sorry, I didn't say hello to you. Swiftblade. We've got Flynn. Hi, Flynn. B, 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 B. Right, you're all on it. I've done that one before, so it's quite easy. What about this one? A router. I'm going to make a bold prediction that the router is going to be in your exam because OCR do love a bit of a router question. They find it hard to resist. And I guess it's because we have this box at home which has got the modem and the router sort of all bundled together. So people often don't actually understand what a router does. So A, B, C, or D, what do you think? Emad has come in with a C, and he is absolutely spot on. Let's give Emad a reassuring ding. I'll tell you what, Emad, seeing as it's you, I think a round of applause is the least we can do for that type of question. I shall ignore that from Swiftblade, but Hash Brown Gaming is on the money, as is Flynn. All right, outstanding. So that's a router. Don't forget that routers are something that they do like to ask questions about. That network hardware, you've got network interface cards, routers, and switches. So make sure you know what they all do, guys. Okay, what about this one? Which of these terms refers to the maximum rate at which data can be transferred? This is easy peasy, I imagine. Which of these terms refers to the maximum rate at which data can be transferred? What do we think? Error detection? Ooh, hello, Emad. Look at Emad. Emad is on fire, literally. This time, Emad, I shall give you a bicycle horn. And we've got Hash Brown Gaming who's got A. We've got Flynn who's got A. Aditya, how are you, dear boy? A for you as well. And Swiftblade, A as well. Outstanding, guys. That's absolutely exactly what it is. Okay, so that was the maximum rate at which data can be transferred is, yeah, bandwidth. Outstanding. Okay, next one. I couldn't resist this. I went for a whole week without asking about registers. But one day, someone is going to get this question right. The question is it going to be today? I appreciate it is the longest question on planet Earth. But if you know this, I reckon you've covered the most difficult part of system architecture, the very first thing they do. So which is which? Which one is A? I want A, B, C, D. So I want you to give me 4 registers in order. Any idea? What do we think? And by the way, Aditya, you were spot on with that previous answer, as were you, Swiftblade. Although you went for a B just in case. But hey, listen, it's all about options, isn't it? What do we think about these? If you don't know them all, so Aditya has said the first is the MAR. You are spot on, right? So let me give you you can have a bicycle horn and you can have some applause. So the MAR, we've done A. What about the rest of it? C is MAR. It's not MAR, you know. It's not Ma. What about the last one? For me, that's the easiest one because that one stands out like a sore thumb. Any ideas? It's difficult, isn't it? So find a mnemonic, find a way of doing it. Oh, I've got some more here. We've got hash brown. C is MRD. C is MRD. Well, is it? I mean, it's MDR, but you are right. So it, apart from you've got your letters mixed up, but that is absolutely spot on. Oh, hello. Emad has gone for. Yeah. Yeah, it is the longest question in the world. That's my bad, to be fair, Swiftblade. Emad, you have got MAR, which let's go through these in order. We've got MAR first. Yep. Then we've got you've said MDR. Ding. And then we've got well, ACC, it's actually PC, program counter, but we'll give you a ding anyway. And then the last one is the accumulator. Did you get that one right? I think you did. Yeah, you did. That's outstanding. That is really good. These are, yeah, I know. There was a bit of a typo there. However, this is what they are. So don't forget the program counter is the register that stores the location of the next instruction to be run. And then the bottom one there, let's just get rid of this hash brown gaming joy here. The accumulator stores the result, okay? And then you've got these two. Obviously, memory data register and memory address register, because don't forget that's what happens. The data is separate from the memory address. Good. Okay. Do you know what? That's the closest we've come to it. I might actually. Oui, ça va assez bien. Un peu fatigué. But I guess it's worse for you. You've had a 6.5 month English paper this morning, which there was an awful lot of it. I hope you guys are keeping it together. Okay, so what's next? This one, what's it all about? How far are we in? 7 minutes. That's about right. A few bits and pieces to cover today. A little bit more technical, this one. So we have worked our way through the first and the second major units, and we're coming to the end of the third one today. So we are making progress here. We kind of hit the halfway stage of paper one. Network security up next, and system software. And I think actually the next two are ones where you can really score a lot of marks. And the last one, ethical, legal, and cultural, that just does, it's practicing your essay writing. So that's where we are. We're in the last point, or last part of 1.3 today. And this is the detail. So we'll talk about wired and wireless connections and the benefits and advantages and so on. Talk about encryption, which is just a few sentences you need to learn. A very good short video on bbc.co.uk about encryption. If you go onto the BBC website and you actually search for encryption, you've got to go through 2 or 3 pages of results. But there's a really, really good short video that talks about public keys and private keys. So worth having a look at that. IP addressing and MAC addressing, the differences and the similarities and standards. Okay, so that is our grand plan today. So benefits and drawbacks, recommending a connection for a scenario, encryption, IP addressing, MAC addressing, and then standards, what are they and why are they useful? That sort of idea, okay? So that's what is required. So let's get into the 5-minute teach and get this done and dusted. So this is network topologies part 3. I wanted to start off with a gigantic, great table for you. And obviously, I'll put this on YouTube, but I will get out of the way in case you want to take a picture of that. I shall vanish. I shall give it 5, 4, 3, 2, 1, and he's back in the room. So this is the sort of information you're going to look for when you're comparing one against the other, because clearly there are situations where a wired connection where you use cables is advantageous, and there are other situations where Wi-Fi or Bluetooth is going to be appropriate. So we'll jump into the wireless in a second, but let's start with Ethernet. Ethernet, the good old-fashioned Cat5, Cat6 cables, they are the fastest way to connect because the transmission rates are really high. Now, obviously, when we talk about over the internet, then fiber optic cable is going to be faster than copper. So Ethernet is a copper cable connection, but it's super quick and the cables are relatively inexpensive. So it connects via an Ethernet port, which is in the back of your computer, and a Cat6 copper cable. It requires a wireless network interface card, and that card at the back of your computer It will accept an Ethernet cable, and it's also a wireless component too. So most devices have both a wired and a wireless ability to connect. Super quick transfer speeds, and it's secure because, well, there's nothing traveling over the ether, so you can't intercept the data unless you sort of get into into someone's cable, which you can't do. So Ethernet is the one that we use at school. It's the one that is the least expensive. It's secure and it's fast, but there are problems with it, and we'll get to that in a minute. So let's have a look at our man like Paul. Thank you for joining us. Good to see you. So let's have a look at the wireless side of it. Now we've got two different technologies here. Everyone's heard of Wi-Fi. Everyone's heard of Bluetooth. So just from the very top, don't forget that Wi-Fi is generally used to connect to the internet. Not always, because you can do a Wi-Fi connection where you connect devices, but usually a Wi-Fi connection is to connect to the internet. But notice that Wi-Fi and internet are different things, okay? Because what Wi-Fi does is that it from your modem, from your router, it takes the internet signal and it converts it into radio waves, and then your device uses it, but it's got to convert it back again. So there's a conversion going on there. But that's Wi-Fi. That's usually to connect to the internet, but it's not the internet itself. And then you've got Bluetooth, which is about connecting devices. You know this because you've got your speakers, headphones, and so on, which you use to connect devices together. Now, Bluetooth tends to work upon a master-slave model, which sounds a bit weird, but in other words, you've got one device that's sort of the boss, and then you connect things to that boss. You know, the pairing that you do with your headphones and so on. There's a difference there. They both use radio waves, Wi-Fi and Bluetooth. Which bit, Swiftblade? Tell me. Was it the slave and master? Yeah, that is a bit weird, isn't it? So the Wi-Fi, they both work using radio waves, okay? And they're both similar in that respect. The range is greater on Wi-Fi than it is on Bluetooth. You know from Bluetooth that if you go more than, I mean, I think even 30 meters is stretching it. I don't think it's that far generally. Wi-Fi gives you a better range. But once you're inside, that range diminishes because you've got furniture, walls, interference, and so on, okay? Those are the radio wave frequencies they use. Wi-Fi is either 2.4 or 5, whereas Bluetooth is the 2.4 gigahertz frequency. So there you've got the different ranges, and Wi-Fi is more secure. Bluetooth is less secure because Bluetooth, if you think about it, doesn't require a password. Sometimes you've got to put in a number, a 4-digit number to pair devices, but there's no passwords with Bluetooth. So if you were so disposed, hacking Bluetooth or getting into Bluetooth would be easier than with Wi-Fi. So I hope that's useful. That's the difference there between a wired and a wireless connection. Where are we at? 43. I think I need to speed up. So let's go on to the next one. And this time it is the benefits and disadvantages of wired versus wireless. I will move out of the way again in case you want to use your mobile phones to get a picture and you don't want my big head in the way. So first of all, the wired versus wireless connection. Okay, so wired gives you a super reliable connection. It's a stable connection. You've got a set number of users only. So for example, if you're using a switch, you've got a certain number of ports into which you can plug cables. So therefore you're limited to a certain number of users. But it's fast, okay? It's the fastest, most reliable, most stable connection. That's why it's so widely used. The problem with wired is that it's inflexible. If you've got 30 ports on your switch and you want to add another user, you've got a problem. So either you buy a new switch or or someone loses their connection. It does mean installing more hardware like cables and switches and so on. And it may involve altering the fabric of the building. It's a fancy way of saying drilling holes in. Do you know what, Aditya? That is actually, let's shove that up there because I could have put that there and that would definitely get you a mark in the exam. Cables are a trip hazard. And given what a litigious world we live in, people tend to sue very easily these days. So yeah, it is. You can trip over them. That's a really good point. Well done. They take longer to install. There's a higher setup cost than wireless because you've got to buy the cables. There's more hardware. I'd put cables untidy there at the bottom, so I was getting close to what you were saying, Aditya. So wireless, it's convenient. You can access from anywhere in the building as long as you can access it. It's got a lower setup cost, BYOD, and I think they might slip this into a scenario. This is the bring your own device. You know, like you can bring a phone or a laptop or a tablet and connect at school. So there's a bring your own device policy, allows you to bring your own device and then connect to the school's or the company's network. It's easy to maintain, less reliant on hardware, and great for connecting many devices and different types of devices. But also, it's really simple to add users. It's very straightforward. No cables, no ports, no switches, nothing. You just connect, don't you? On the negative side, you've got interference. Now, interference could be in the form of other electronic devices, which can then cause interference, cause a magnetic field, a magnetic signal, which will reduce the speed of your connection. And sometimes I had a situation here at home where I had to change the frequency of my connection for the broadband because it was being impacted by next door's broadband who were on the same frequency. It is less secure, which makes unauthorized access easier and means that you're more open to data interception. In other words, someone stealing your data, intercepting your data. Okay, thick walls, metal buildings, furniture, and it's slower. So wireless is slower. But as long as you've got a hatful of those that you can take into this part of the exam, you'll be fine. But make sure you have got a good number of pluses and minuses of using wired versus wireless. Where are we? 46. Quite a lot to get through there, but hopefully, I imagine most of those make sense to you anyway. Maybe draw a little mind map or do the table that I've got there. But I'll send you the PDF for this. Now, this is my guesswork here because if you remember in the spec at the start, there was this possible scenarios they could ask you. So they could say for a given type of building, so a metal building would be a bad choice for Wi-Fi because it blocks the signal. Buildings with thick walls, bad idea. Very large buildings, you know, the Wi-Fi range might not be adequate. What about a set or a flexible number of users? If the number of users can change regularly, you'd probably want Wi-Fi. If you've got a set number of users that's never going to change, it might be a cable connection, a wired connection that's better. If they gave you the example of a cafe, and I was thinking here, the reason I put that in there is that, say, for example, it would be a benefit to the customers to offer a bring your own device policy so that if people went to a cafe, you could give them the Wi-Fi password and then they can connect to the internet. If that gives your business a boost, then that would be a reason for choosing that. So I've just thought through some ways in which they could write a scenario. They'll probably use someone called Alicia. They like Alicia in their examples. And Alicia will be deciding which, whether to go for a wired or a wireless connection. So if you know all that stuff from the previous slide, it allows you to think across what might be a better solution. And as long as you come up with a decent number of reasons why you would or wouldn't use wireless or wired, you should be all right. So that's what they could do. They might not do a scenario, but they can do one. Okay, so those are the possible scenarios. Let's look at encryption. I'm going to whiz through this because you've done it before. Encryption is when you turn plain text, so just text that you can read normally, into ciphertext, where the text gets scrambled. And if it is scrambled, and if you encrypt your data, it means that if it's intercepted, for example, by a man-in-the-middle attack, data interception, it means that it's unintelligible. So even though you might lose the data, the person who's stolen it can't read it because it's scrambled. I talked about the private key versus public key encryption. Have a look at that BBC video. It's really useful, only about 2 minutes long. Don't forget keywords, encryption, which means you scramble it, and decryption means you unscramble it. And that's also in system security. So I've whizzed through encryption, but I think it's pretty straightforward. Plain text into ciphertext. That's what will get you the mark in the exam, okay? IP addressing, 11 minutes. IP addressing. IP stands for Internet Protocol. A protocol is a set of rules or standards. And I'm coming on to standards in a minute. Rules are really important because that way everyone can write according to the same rule book. If different companies use different rules to make the same sort of systems, then nothing works together. There's no cross compatibility. Okay, so the IP addressing governs the format, the way in which the data is formatted, put together, the way that it's Yeah, let's stick with put together, between TCP and IP networks. So how the data is arranged, there we go. When it's set between TCP and IP networks, it involves a unique address. So your IP address is unique to you. It is yours. It's a set of numbers, and it is your address, and it identifies a device on the internet or on the local area network. It's also an identifier, as in it's a postbox, number 4 Castle Street. It's a bit like that, okay? It's so the data can be sent to a specific location, and it also allows devices to be accessible or open to communicate. It allows them to be able to communicate. It's a string of numbers separated by full stops. Yeah, okay, so I knew, Emma, this would come from you. What if you use a VPN? VPN's the way you can hide your IP address. So if you wanted to look at content from a different country, you'd use a VPN, because that way it's very difficult to block you. And that's exactly what a VPN does. It spoofs your IP address. So the other thing that you need to know is that an IP address can be changed. You might find you use the same IP address each time that you get onto the internet, but the IP address can be changed. Change your location changes the IP address. Change your hardware, the IP address can change. Okay, it's not linked to the hardware, so the IP address you are assigned by your ISP, your internet service provider, and while you might have the same one, the IP address can change. Okay, there's a whole dynamic static IP address thing, but that's dropped out of the syllabus now, so we don't need to learn that. IPv4 versus IPv6 is simply the IP addressing system. Now, IPv4 is 32-bit, which meant that they had a grand total of 4.3 billion possible IPv4 addresses, but that wasn't enough. We've now used all of those. So that's why they've had to go with IPv6, which is 100, I'll go this way, 128-bit binary number. And if your maths is anywhere half decent, you'd have worked out that that is 340 undecillion different addresses you could have, which is so many that I don't know where to start. So we ain't going to run out of those. So that's your IP addressing. 8 minutes to go. The next thing we're going to look at is MAC addressing. And they will ask you a question that involves you understanding the difference between them, okay? So IP addressing is for when you go onto the internet, TCP/IP, Transmission Control Protocol, Internet Protocol, which is the set of rules that governs how data is moved and how it is how it's moved across and how it's formatted. There's the word I wanted, how it's formatted. MAC addressing. Every piece of hardware that you buy has its own hardwired MAC address. Unlike IP addresses, this cannot be changed. It's hardwired into the device. So your phone, your PlayStation, your Xbox, your tablet, your computer, they have got their own MAC addresses. Now, MAC addresses are usually more relevant over a local area network, and it's how you can find your printer and how you can find your peripherals and your different hardware. Okay, 48 or 64-bit binary number this time that's converted into a hex number, and it's used by the Ethernet protocol. So the Ethernet protocol is, guess what? The set of rules that governs how data is formatted and sent on a local area network. So you've got LAN versus WAN, haven't you? And the wide area network, the internet, that's more about IP addresses, whereas on the local area network, it's all about Ethernet, because that's the protocol that's used. Whew, there we go. MAC address is used by switches to direct data to appropriate device. Okay, so that's the MAC address bit there. 6 minutes to go. Gosh, there was a lot here. Some might say too much. All right, standards. Standards is actually really straightforward, but they haven't asked a question on standards for a couple of years, and they changed the format of this in the current syllabus. So I've got a suspicion that may be something they do. So standards are a set or an agreed way of doing things. What's the benefit? It makes it simpler to build software that works on different platforms or systems, because people are writing software or creating hardware to the same set of standards. I mean, an example would be, you know, the 3-pin plugs that we all use at home. And obviously, if you go to India or Pakistan, different plugs. If you go to the States, different plugs. If you go to France, they've got the 2-pin ones, the ones that we've got for our shavers here. So this is the idea that these standards they stick to. Bluetooth is a standard. Wi-Fi is a standard. So if you buy a Bluetooth enabled device, it'll work with any other Bluetooth device. The opposite would be, think about Apple, who love to bring out weird and wonderful new new sockets and plugs that only work on their devices. It's really annoying, isn't it? And the USB 3, that's a standard that's been widely adopted everywhere. Even Apple have used it. So these are all examples of standards. So what you need to take from this are these advantages, such as it's easier to work or to collaborate on projects. It ensures wider compatibility, okay? And it's a set agreed way of doing things. 5 minutes. Am I into the quiz? I am. Woo! Okay, 5 minutes. Easy peasy. Fingers on buzzers, please. Wireless transmission is slower than cabled. Is it A, true, or B, false? What do we think, my geniuses? What do we think the answer is? Oh, it's A. Look at Emad. Emad is on fire. I mean, I hope not literally, but let's move on to the next one. Emad, you are a superstar. I shall give you a special ding. It is A. You are amazing. Next one. BYOD is easy to implement on a wired network. What do we think? And by the way, Aditya, you were right. Swiftblade, you were right. And Hash Brown Gaming, you were right. But what about this one? BYOD, bring your own device, is... Emad's coming in with a B. Emad is the man. You are absolutely spot on. I shall give you 2 dings, swiftly followed by Swiftblade. Absolutely spot on. Okay, well done. And by Hash Brown Gaming, you guys are on it. Right, let's get a move on. 5 minutes, we can get these done. Next one is, what does IP stand for? Internet protocol, or internet packets? What do we think? Easy peasy. I know you know this. What do you reckon? Yeah, B. Okay, we've got B. We've got B. Yes, that was Hash Brown Gaming, I think. B. Oh no, it was down there. Emad. It was first. I think it was Hash Brown Gaming. Well done. You can have a special ding. Ding. That is outstanding. Yep. Okay. What's next? Hopefully a harder one. Encryption is effective against SQL injections, DDoS attacks. Probably the most difficult one to get your head around, DDoS attacks, but we'll do that in 2 weeks' time, I think, or is it in a week's time? And data interception. Which one? Oh, did you? Swiftblade, I take it all back. I apologise humbly for ruining your family name. Emad has said data interception. God, Emad, you are on it. Ding, ding, ding. We've got Swiftblade with C and Hash Brown with C. Guys, you're absolutely spot on. That is exactly what it is. How long? 3 minutes. We can do this. It is indeed about data interception. So let's go on to the next one. MAC addresses. Change each time you connect to a network, can be changed or cannot be changed. Do you remember? One can, one cannot. And that's probably what they're going to ask you about. I doubt they're going to get into, Emad. You are, I think it was Emad again. That was outstanding. It is. They cannot be changed. That's what MAC addresses do. Swiftblade, Swiftblade, you know what? That is going to be your IP address more. Hash Brown Gaming, you're on there. That is good. Okay, let's push on. How long left? 3 minutes. We can do this. Okay, IP addresses deal with the format of data when using TCP, deal with the format of data when using LANs, deal with the format of data when using TCP IP. A slightly sneaky and nasty one, this. What do we think? Ooh, B with Aditya. Interesting. And when I say interesting, I mean, what am I trying to say here? Yeah, I mean, it's wrong. Oh, look at Swiftblade, straight in there with a C. Ding! That is what they do, okay? Emad again, in with the C. TCP IP, Transfer Control Protocol, Internet Protocol. It wasn't wrong, B, Aditya, but C was more right, if that makes sense. I'm not sure it does, really. Okay, where are we? Whoa, 1 minute left. I'm not going to go over. Oh, here we go. I think we're almost there, actually. So what is this? Guess the question. By the way, guess the question answer. This was the answer here. Defines rules for data transmission, defines standards for data transmission. What do we think the question was? Do you know what? I'm going to tell you. The question was, define what is meant by network protocol. So you see, that's the area that they're pushing around in. It's 7 o'clock, which means that our carriage turns into a pumpkin. So wireless transmission slower. What is internet protocol? Ooh, well, internet protocol, IP, is a set of rules that governs how data is formatted and sent across the internet. Okay, and there's more of that later on. Right. So I think, guys, it is 1900, and I'm not going to do this one. I'm simply going to say to you, because it's my bad for making too many things. Revision ideas, basically everything we've done are the revision ideas. What are the advantages using wired over wireless? They are, it's faster to use wired, and it's more secure. Okay, and that table that I produced for you has got a few more things in there as well. So next week I've got a minute over, which is against my principles here. This is next time, guys. Okay, TCP/IP, HTTP, and so on. Next week's one. This is oh, that was you asked the previous question. I apologise. Next week's one. This is quite challenging. Okay, because you don't need to be able to explain in graphic detail about all of these, but you do need to understand what they do. So these are all the protocols, and I'll give you a bit more about what each of them does next week. Guys, have a lovely evening. Good luck with the rest of your mocks. I will see you a week today, and we can do all of this. Take care, guys. Have a good one. Bye-bye.